Welcome to another day on the Journey Chez Chem. Well, today we're going to be talking about electrolytes, and we're going to show some excitement here, and so I can't wait for you to do the warm-up so we can come back and see you soon. In number one, we need to determine the identity of these different compounds. And when I look at potassium is +1 and oxide is -2, it's K2O. That is a metal with oxygen, and that would be a base anhydride. The next one is zinc chloride. Zinc is +2, chlorine is -1, and therefore I need 2 chlorines to get my compound to 0. Calcium is +2, hydroxide is -1. Calcium hydroxide is a base. Zinc chloride is a salt. A metal with a nonmetal or metal with a polyatomic ion is a salt. Metal with hydroxide is a base. Nitrogen, this Roman numeral is telling me that nitrogen has a +1 charge and oxygen is -2. Therefore, this formula is written in this way, and it is a nonmetal with oxygen, and that would make it an acid anhydride. Iron is +3, nitrate is -1. Therefore, I must have 3 nitrates in order to get my compound to 0. And this is a metal with a polyatomic ion, which makes it a salt. Finally, hydrogen is +1 and carbonate is -2. Therefore, I need 2 hydrogens in order to get my compound to 0. And we are now going to be calling this compound carbonic acid. It begins with hydrogen, and therefore it must have an acid name. That's what we're learning during this topic. Number one has us identify these compounds. That's the first thing we must do. In number 2, we are asked, what is an electrolyte? An electrolyte is a substance, when I add it to water, it breaks up into particles, it dissociates or ionizes and can conduct a current. It is required for electrons to be able to flow to conduct a current. And when we add an electrolyte to that water, it breaks up into these ions, and therefore it can conduct a current. And I am going to show you an example of that. Now, I was able to go get my outfit that I needed to have on to be safe. I need my safety goggles to protect my eyes from any splashing or chemicals, and I need an apron in order to protect my clothing, and I tied my hair back. So these are things we need to do before we go into the lab. And now, I have here a light bulb that has some electrodes that are sticking out here, and in order for the light bulb to go on, it must complete the circuit. And that's why we call electrolytes electrolytes, because they break up into ions and allow the current to flow. Now, I have this one in the water, and water is a non-electrolyte. Therefore, the light bulb does not go on. Non-electrolytes cannot conduct a current. Now, the water that you have in the tap has ions in it, and those ions that are like calcium ions and magnesium ions and sodium ions for soft water, then you would have the ions then, and the light bulb would look very bright, which is the one that I'm going to show you next. Here we have some sodium chloride. Sodium chloride is a salt, and all salts are strong electrolytes except for the mercury salts. And you can see that this is a very bright light. It's It's a strong electrolyte. There are many, many ions in here. Strong electrolytes have 100% dissociation, and that's what makes them strong. Then I will rinse my electrodes in my distilled water, and I will now put them into acetic acid, which is vinegar. And notice that the light bulb is very dim. It doesn't have as many ions, so it can't conduct as much electricity. It's very weak. It's a weak electrolyte. And there you have it. It's not one of my 7 strong acids. It's a weak acid. My 7 strong acids are hydrochloric, hydrobromic, hydroiodic, nitric, perchloric, chloric, and sulfuric. If it's not one of these 7 strong acids, it's a weak acid, and it would only light up the light bulb a little tiny bit. And there you have it. That's how we distinguish electrolytes. Today we have to talk about 5 different types of reactions. I'm going to give you 2 of them that are called neutralization. And you might have run across these before because they're pretty common. If you have an acid plus a base, you will get a salt plus water. And likewise, if you have a salt plus water, you will get an acid plus a base. Now, oftentimes when we take salts, and we're going to do a lab on hydrolysis about this, where we will take salts and put a drop of water and determine their pH. This acid is actually called a parent acid and a parent base. And the parent acid and the parent base will tell us what type of solution that we are going to have, if it will be acidic, basic, or neutral. So let's take a look at an example of that. A very common salt is sodium chloride. That's the one we're most familiar with. Plus water, and when I write water, I write it as HOH because it splits up as hydrogen ions and hydroxide ions. That's how water separates. We're going to do the do-si-do. We're going to trade partners. And when we have a salt plus water, we know that we're going to get an acid and a base. And the acid always has to start with hydrogen. So we'll get HCl, hydrochloric acid, and sodium hydroxide. Then I look and see hydrochloric is one of my strong acids. And sodium hydroxide is one of my strong bases. When I look at the penguin sheet, I see that the strong bases are group 1A and 2A with hydroxide, except for beryllium. So both of these are strong. If both my acid and base are strong, or both are weak, my solution will be neutral. If one is strong and the other is weak, whichever one is strong will win. So if I have a strong acid and a weak base, my solution will be acidic. If I have a weak acid and a strong base, my solution will be basic. And those are neutralization reactions. And we'll have some experience with this in lab, and then you'll become a lot more familiar. The next 3 types of reactions are interrelated. When we have an acid anhydride, I remember that anhydride means without water. So if we have an acid anhydride and we add water, we are going to get an acid. That seems pretty straightforward. If we have a base anhydride and we add water, I'm sure you know that we will get a base. And if we have an acid anhydride plus a base anhydride, now when I had an acid and a base, I got salt and water, but there's no water in here. So all I can get is a salt. To do this equation and this equation takes a little bit more effort. And we will go through some example problems. Let's take the acid anhydride you had in the homework. It was Cl2O3. Now, when we add it to water, we're going to get some form of an acid. And the way to know is that I have to find the oxidation number of this chlorine. And we've done this numerous times. It is +3. Because oxygen is -2, there are 3 of them, which gives me a -6. There are 2 chlorines, and therefore each chlorine is +3. Now, I know that the acid will start with hydrogen, and hydrogen is +1. And chlorine, we found out, had to be +3. Together, that is +4. So it must have 2 oxygens to get to -4. Each oxygen is -2 times 2 is -4. And that is the way the compound works. Now, I am not concerned that you balance these equations at this time. The compounds on this side are called reactants. And the compound on this side of the arrow, the right-hand side of the arrow, is called a product. Now, to me right now, I'm not concerned that you balance the number of atoms. I just want you to be able to find the correct compound. I could have also found the right polyatomic ion because I know that I have perchlorate, chlorate, chlorite, and hypochlorite. And only in this case is chlorine +3. In this case it is +5. And here it is +7. And here it is +1. So you need to go back through on the penguin and maybe solve for the charges of these chlorines in that polyatomic ion, because we are going to need to know that. Now, then when you get to an acid anhydride plus a base anhydride, then it also becomes more complicated. I'm going to use the one that we started with here of Cl2O3. If you have Cl2O3 plus K2O, first I have to identify what kind of compound I have. I have an acid anhydride plus a base anhydride, and I know that I'm going to get a salt. Now, a salt is a metal and a nonmetal, but because we have so many oxygens, we have to get a metal and a polyatomic ion. Well, potassium is my metal here. And the chlorine here had a charge of +3. So I know that the polyatomic ion, ClO2 with a -1, the charge of the chlorine is +3. -2 times 2 is -4. The polyatomic ion must be -1, and therefore chlorine is +3. And therefore my salt will be KClO2. We'll have some practice with these. They are challenging, but I know you can do it. We'll have some practice. Tonight you have 5 to work on, and you just do the best you can, and we'll go over it tomorrow with your facilitator, and I can't wait to see you tomorrow. Bye.